Hi guys, we're back, and this time fault finding on a Baxi 800 series combi. Take notes, write down resistances, ask questions in the comments below. Thanks for watching, like and subscribe. First things first, always play safe. Check that's a 3 amp fuse. Blow the fuse before you blow the PCB. First fault, 118. That means low pressure. Top it up using this valve. Or look underneath the appliance, you might see like a circular braided hose with 2 black handles on, or a slot for a screwdriver. Try that, that might help you. So before we begin, let's have a quick recap on multimeters, shall we? So first things first, on your multimeter, squiggly line, that's AC, alternating current, which is 240 volts AC. That's for things like your pumps, perhaps a fan, perhaps a diverter valve. This is direct current. That's your pressure sensor, flow switch for the hot water. Direct current is low voltage, but it's also constant voltage. Here we have resistances, and this is for the NTCs and the motors of things like the gas valve and the diverter valve. Resistances, when you're setting your multimeter, remember it goes from 200, 2k, 20k. So just be apprehensive where you set the resistance reading. So this one will be for the gas valve, this one will be for the NTCs, this one will be for the HT lead. And remember, 3 amp fuse. First things first, let's check the flow and return NTCs for the heating system. So to do this, the first thing we need to do is to check the resistance reading. So here goes. I'm going to disconnect it. I'm going to put my probes across it. The power's off and I've disconnected it. And we're looking at about 10,000 ohms. So it's not quite 10,000 ohms, but it's a little bit colder than 25 degrees. The flow NTC is just there. If you think the NTCs are faulty, move it 1/2 inch. And that will rectify it. Right, let's check the gas valve. So for the gas valve, I'm going to unscrew the harness. So to check the gas valve, the top pin and the lowest pin should be 45 ohms. (42, 43). So that tells me it's good. It's a good component. There it is for a closer look. Top one and bottom one. So when it comes to using a multimeter, you use it to confirm whether a component is functioning correctly. Maybe the bearings are faulty. On an NTC, there's nothing really to adjust or find out. You know, the resistance readings will tell you the temperature of the NTC. If they're faulty, it'll give you the wrong temperature. I'll talk about that later on. On a gas valve, the resistance reading should have been 45 ohms. So you're allowed 10% of that. So let's say 5 ohms. So really, it should have been between 40 and 50 ohms if the component was adequate and good functioning. So just there, we have a flue temperature sensor, the NTC. That should measure about 25,000 ohms at 25 degrees. So before we go investigating with the hot water, let's see if there's a demand there, simply by looking at the interface. So first test, you can see just there, look, you can see a tap symbol, but it is not flashing. So now I'm going to put the hot water tap on and see if it registers the demand. Tap is flashing, so it registers the demand, and that tells me the flow switch is working. No hot water. Whoa, is there a demand first of all? So that red section there, that's the flow sensor. That will activate and send a signal to the boiler when water is rushing through it. So, just there, and see if a red light comes on, because some flow switches have lights on. Here goes. There you go, you can see it lighting up, look. So this is a diverter valve now for the hot water and heating. So we're going to check the resistance. The resistance should only go to one component. So there's two components in this head, isn't there? There's two windings, one for the hot water demand, one for the heating. And we're looking at 7,000 ohms. The middle spade is the neutral, and the other two is the power to the windings. So we're looking at 7,000 ohms. Okay. It's at 20k ohms resistance, because I'm looking for 7k, so it's above 2k, below 20k. Neutral in the middle. There you go, 7k. I'm happy with that. That motor's good. The next thing you can do is check 240, putting that in there, and that in there, and selecting 200 volts AC. So now I'm going to do another test on the diverter valve. These diverter valves are pretty good, to be fair. I'm going to actually check it moves. So I've checked the resistance, I've checked the gain demand. Now I want to see if it actually moves by actually putting a screwdriver in it and see if it moves. How exciting, brilliant. So there's the pin, it's at the back. Now I'm going to put the heating on and see if the pin moves up. I'll be ready. 1, 2, 3. Just to confirm, hot water demand moves the pin to the motor. Here the pin is down, as you can see. Now I'm going to put the heating off by putting the hot water on, because it's hot water priority on combis, and we're going to see if that pin moves up. So now let's look at the hot water NTC, and for this NTC, it's this one. Ta-da! So this one, you lift up the tab, disconnects the cable, and you put your probes on. So even though the NTC is slightly different, it should have the same readings as the flow and return. 10,000 ohms, 25 degrees, and here it's a lot colder. Before we go fault finding, you must always look at the interface. Is there a fault code? Is there a smell? Is there a noise? And not only that, is there a demand? An appliance, a boiler or heat pump might not be faulty. Maybe it's not getting a signal or a call to actually function. Ignition problem? Get your torque screwdriver out and check the gap on the electrode. Take it out, have a look. The next thing to check is the HT lead, and for this the resistance is 1000 ohms. So there we have the probes, either end of the electrode. Almost 1000 ohms. So that is good. That is in good nick. Knowledge builds trust. So when you're fault finding, you've got to explain to a customer what's caused the fault. You've got to give them that indication. Was it dirty water? Was it magnetite? Okay. Was it being worked too hard at maybe too high temperature? And explain that to them. You can get more work. But also, when you're fault finding, present your knowledge. So what you can do is you can explain to them what you've used to rectify it and how you came to that result of that component being faulty. So for example, the diverter valve, you could say I did a resistance reading, there was 240 volts power to it, it wasn't moving under demand. And it just builds a case up and it gives you a good reputation. And when you're walking around the street in the community, you want people to speak highly of you. Hey, you see Jonathan Hallam, that bloke with that big forehead? He did a great job on my boiler. So now we're going to check the high limit safety device. For this you can do continuity. That looks like the Wi-Fi. Beep. My multimeter doesn't have it, so I'm going to put it on resistance. So it shouldn't have any resistance, it should just go straight through. So the multimeter, I'm expecting a 0. If it's faulty, it'll give me a 1. Clip it off. And pull your spades off. Here we have it. So people think these have a chemical in. They don't. It's 2 strips. Just that. So my current resistance on the multimeter is 1. Because they're not touching. Touch them. 0. No resistance. So let's see if this works. Put it through there. Into there. No resistance because you just go straight through. That's a good high limit stat. Here we've got the pressure sensor, and most of them have 5 volts DC supplying it. So switch this to DC, straight line on the volts. AC is a wiggly line, look. So I'm going to put this on an earth or the casing. I'm going to put this one on the spade, and I want 5 volts DC. 5 volts DC spot on. So that's getting power supply to it, isn't it? Flow turbine, flow sensor, flow switch for the hot water, 5 volts DC. Thanks for watching, guys. Please make sure you like and subscribe.